All right, welcome back. Today we're going to be talking about the nature of matter, and this is going to be our first topic in our biochemistry unit. So, you may be asking, why are we going to be talking about chemistry when we're in biology class? And the answer to that is because chemistry is the foundation of biology. Everything that happens in biology has a basis in chemistry. Therefore, this is going to be very important in biology. So everything is made up of matter. So everything in the world is made up of matter, and matter is made up of atoms. Atoms are going to be the smallest unit of matter, meaning they can't be broken down any further chemically. So atoms are the smallest unit of matter, and matter cannot be broken down any smaller than into atoms. The difference between an atom and what you guys know as an element is that an atom is one singular molecule, or not molecule, but one singular atom unit, versus an element is it can be many different atoms held together. They just have to be the same type of atom. So one atom of oxygen, you can only have one. But if you have 5 oxygen atoms, that could be considered an element. So an element is something that's only made up of one type of atom. So each type of atom is known as an element. So every type of atom is known as an element. And everything in the world is made up of a different combination of elements. So when we're talking about any number of things, it is all made up of different combinations of elements. So now we're going to talk about the structure of an atom itself. When we're in biology, just know we're going to be talking about 4 types of atoms or elements in particular. We're going to be talking about carbon, oxygen, hydrogen, and nitrogen most of the time because 96% of living things are made up of those 4 elements. Another 4 that is found in living things, but it's found in only trace amounts, are phosphorus, sulfur, calcium, and potassium. So those are the ones you're going to be focusing on in this class. Versus chemistry, you're going to be learning about all of them. So the structure of any one atom has a core or a center called the nucleus. So the core or the center of an atom is called the nucleus. So if I was labeling here, this center part here would be the nucleus. The nucleus itself is made up of 2 different parts. There are the positive protons in the nucleus, P for positive, and the neutrons, which have no charge because they are neutral. So here in my nucleus, I have the ones with the positive charges, and those are protons. And then I have the ones with no charge at all, and those are neutrons. Neutron for neutral. Outside of the nucleus, found in rings circulating the nucleus, are electrons. Oop, I wrote that in the wrong spot. So again, circulating on the outside of the nucleus are the electrons, and electrons have a negative charge. So again, electrons on the outside of the nucleus has a negative charge. Now the electrons, if you notice here, there are 2 rings of electrons on this particular atom that we are looking at, and each ring is called an energy level. So the electrons move around the nucleus in different energy levels. Depending on the atom, it's going to determine how many energy levels or how many rings it has circulating the nucleus. The most important electrons in the atom are going to be the electrons in the outermost shell. So the ones out here, then the outermost ring, are the ones that are going to determine how this atom reacts chemically, and those are called the valence electrons. And again, valence electrons are the electrons found in the outermost shell, outermost energy level of the atom. Now, in order to be considered stable, that outermost level is going to want to have 8 electrons. It wants to have a full shell to be considered stable. And in order to be stable, atoms are either going to gain, lose, or share these outermost electrons so that they have a full valence shell and are therefore stable. And this ability to gain, lose, or share electrons is going to contribute to how different atoms form chemical bonds. So chemical bonds are made by atoms gaining, losing, or sharing electrons, and therefore interacting with one another. When we are talking about bonds, it's good to know that a compound is a substance that is made up of one or more joined atoms of different elements. And how these interact with one another, again, all depends on the valence electrons. Because in order to be stable, chemically stable, an atom has to have a full valence shell. And again, if it's not full, it's going to do everything and anything it can to become full. And that is going to determine the type of bond that that atom will make with different atoms. And there are 3 types of bonds we're going to talk about that atoms can make. We're going to do the weak bonds first. The weakest bond that an atom can make is called a hydrogen bond. Right now we're just going to mention them, and later we're going to talk about them a bit more in detail. The second type of bond that an atom can make is called an ionic bond. And then the strongest bond that we're going to talk about is going to be called the covalent bond. So we're going to go into some details on these types of bonds and how they are made. So first we're going to talk about the strongest bond, which is the covalent bond. The reason why the covalent bond is the strongest type of chemical bond is because in a covalent bond, the atoms share a pair of electrons. And when you're sharing something, it's going to be much harder to break those 2 atoms apart. So an example here of a covalent bond is hydrogen gas. And hydrogen gas, they share these 2 electrons. Both atoms are holding on to those electrons fairly tightly. So it's very hard to split them up. And this type of bond is what's going to form a molecule, which is a group of atoms held together by covalent bonds. Therefore, molecules are relatively stable and hard to break apart. Now, sometimes there is another category of covalent bonding called a polar covalent bond. And a polar molecule is charged, and it has poles. So one end of the molecule will be positive, the other end of the molecule will be negatively charged. And the reason that a molecule is charged would happen because electrons are not shared equally. So the unequal sharing would cause the molecules to be charged. So one example of a polar covalent bond is in a molecule of water. So a water molecule, there's a water molecule drawn over here. There's one large oxygen atom two smaller hydrogen atoms. The oxygen atom has a higher attraction for the electrons than the hydrogen. Therefore, the oxygen atom is going to hold the negative electrons closer to it. The way I like to think of this as if you have two siblings. The older sibling has a favorite toy, and they have to share with their younger sibling because their parents said that they had to. But since this is the child's favorite toy, they're going to share, but they're not going to let that doll get out of their sight. If it's their favorite toy, the older child is going to share it, let their younger sibling play with it, but it's always going to stay in their room. They're going to have an eye on it. They're keeping that toy pretty close to them because it's their favorite. It's not shared equally. It's shared, but you have that toy with you unless your sibling wants to play with it. So it's with you most often. So that means the same thing happens here between oxygen and hydrogen. The oxygen wants to hold these electrons much closer to it. And if you hold something negative really close to you, you become negative. That means that the negative electrons are being pulled away from the hydrogens. Therefore, the hydrogens become more positive. If you keep something negative far away from you, you're positive. If you keep something negative close to you, you are negative. And that's going to make this water molecule have one end that is positively charged. This is a positively charged end of the molecule. And one end of the molecule is negatively charged. And having those opposite poles makes water a polar molecule. And again, this is caused by oxygen hogging the electrons and keeping them closer. So again, if you have something negative close to you, you become negative. If you have something positive or something negative far from you, you become positive. Another way you can remember this is just by the looks of it. The H looks more like a plus than the O. So that's one way you can also remember it. Hydrogens are positive. All right, so now we're going to talk about ionic bonds. And in order to understand ionic bonds, you first have to understand what an ion is. So an ion is any atom that has gained or lost an electron. And the way ionic bonds work is you have two molecules. So here at the bottom, we have sodium and we have chloride. One atom is going to lose an outer electron. So if you look here at sodium, if you look in the outer ring, there's only one electron there. So in order to have 8 electrons in the outer ring, it just has to get rid of this one electron. And if you get rid of something negative, you become positive. So now this sodium is positively charged because it got rid of an electron. The other atom in the pair, so this one, it got rid of it. The other atom in the pair is going to gain an electron. And again, if you take on something negative, you become negative. So in this case, the chlorine atom takes in an electron. It only had 7, it took in 1, now it has 8 and it's stable. And because it took on something negative, if you take in something negative, you become negative. And now these two molecules can stick to one another because the negative and the positive are attracted to each other because opposites attract. And this is going to form a weak bond. And the example we talked about here with sodium and chloride is essentially what you guys know as table salt. This type of bond is what forms table salt. Sodium, it has an extra electron in its outer shell. In order to be balanced, it gets rid of it. When you get rid of something negative, you become positive. Chlorine has one too few electrons, so it takes on an electron. If you take in something negative, you become negative. And now the positive and the negatives attract and they stick together and they become sodium chloride, also known as table salt. All right, and the last type of bond that we had talked about was the hydrogen bond. And we said that the hydrogen bond was a very weak chemical attraction. And this happens between polar molecules. Now you might be thinking, where do you get this name hydrogen bond if it's between polar molecules? And it's because if you notice over here in this image, hydrogen bonds typically form between a negative and a positive atom, and the positive atom a lot of the times is a hydrogen. So it's attracted through this hydrogen. So again, polar molecules are ones that have become charged on opposite ends. So one end is positive, one end is negative, therefore it has poles. The one that we talked about was water. In water, the positive hydrogen of one water molecule will be attracted to the negative oxygen of another water molecule. So the bond, a hydrogen bond, is drawn here. I'll draw it again over here to the side. And I think, nope, it's not. I was thinking there was a question in the review about it, but it's not. So if I draw it over here, here's my oxygen atom. I have two hydrogen atoms. Again, my oxygen is negative, hydrogens are positive. This is one water molecule. I have a second water molecule at the bottom, identical to the one at the top. Oxygen is negative, hydrogen is positive. A hydrogen bond is going to form between two polar molecules because the positive end of one is attracted to the negative end of the other, and that creates a hydrogen bond right here in the middle. And this is the weakest type of bond. All right, so going to our review. What is the difference between an atom and an element? So if we go back up to the very, very top, an atom is the smallest unit of matter. Each type of atom is an element. So an atom is the smallest unit of matter. Each type of atom is called an element. So that's number one. Number two, what charge do protons, neutrons, and electrons have? Protons, P for positive. Neutrons are neutral, no charge. Electrons are negative. Okay, it says distinguish between an ionic bond and a covalent bond. Give examples. An ionic bond happens between, I'm going to abbreviate BTWN, between ions. Again, ions are molecules that have gained or lost an electron. And our example is table salt. Covalent bonds are sharing of electrons. And an example of that is the bond that's used to form molecules. If we go up here to the image we already have, the bond that holds the oxygen and the hydrogen together in the same molecule of water, this is a covalent bond. Okay, what is a polar molecule? A polar molecule is a molecule that has a positive and a negative pole. So a polar molecule is a molecule that has one end that's positive and one end that's negative, like water. The weakest type of bond is the hydrogen bond. So the weakest type of bond is the hydrogen bond. Okay, So that wraps it up for nature of matter. There will be some practice after this for you all to do on your Canvas page.